If you're looking on the Ready, Set, Go here, do you guys see this table? So they're giving you a sentence in words, okay? And then they're they want you to translate it into a math sentence. Okay, let me pause the video. All right, so we're trying to translate from English to Mathlish, basically. Okay, so if you look at the example, they say, I'm thinking of a number. A number is X. That's why they start with X. Okay, I'm thinking of a number that is greater than 13. So that would be X is greater than 13. So in Mathlish, this is what it would look like. X is greater than 13. That's what they're saying. That's the whole reason we want to write the inequalities, is so we don't have to write out all the freaking words. Go ahead.
You guys be quiet so you can film.
So the second one says, I'm thinking of a number that is at least 13. Okay, so I'll start with the X. But now what's the sign going to look like?
Greater than 13.
So if it's at least 13, that means it can be 13 or bigger, correct? So that would be X is greater than or equal to 13. Greater than or equal to 13. We're not going to do all these because a lot of them say the same thing just in a different way. But you have some of these on your quiz. There's 4 of them on your practice quiz. So I want to make sure that you guys know what it's asking you. Okay, so let's go to the next one now, number 2. I'm thinking of a number that is no fewer than 13. So if it can't be fewer...
Oh, really?
Yeah, it's weird the way they say it, right? It makes you want to say less than. But if it can't be fewer, it's basically asking the same thing. The number has to be at least 13. 13 or above. So these two are actually going to be the same answer. That's why it kind of gets confusing. So we're not going to do all of them. I just need to make sure that you guys can, from words, figure out if it's a less than sign or a greater than sign. Because we're going to start solving word problems where you'll have to create the inequality. You'll have to know if it's less than or greater than. And the words are going to be in the word problem, but they're going to say stuff like no fewer than or at most 13 or whatever. Okay, so let's do the next one, 3. Now I'm thinking of a number that does not exceed 13. So it's got to be less than. Can it be equal to? Because 13 technically doesn't exceed 13, right? They're the same. So it can be less than or equal to for that one. Good. I heard you, Ramiro. You said equal to. You were right. All right. So somebody pick one more to do. 10. Okay, so 10 says, I'm thinking of a number that is not greater than 13. Good.
It didn't say it couldn't be 13.
Exactly. So it can be equal, and it could also be less. It just can't be more. So X is less than or equal to 13. Let me find one that doesn't have an equal to, so that way we can... Let's do 6. 9, you said? So if it's not under 13, it can be greater. It could also be 13. So that would be a greater than or equal to.
How about 8? 8, it's less than
8. 8 says a number strictly less than 13. So if it has to be less, it can't be equal to 13. It's got to be under. So that would be just a regular less than 13. Does that make sense? Okay, you're going to have 4 of these on your practice quiz. It's one problem. There's 4 parts to it. And you just pick the drop-down menu. Okay? So now I want you guys to go down to number 11. Okay, I know there's not a whole lot of room on here, so you might need to write the stuff over here on the right or something.
Or just small.
Or small. Somewhere in the margin, I don't know. But what we're doing now, okay, is we're going to create an inequality from the word problem, and then we're going to solve it. Okay, we haven't done this yet. I've just been giving you the inequalities. You've been solving them. So now it's going to be kind of the same thing, but an extra step. So we have to read the problem and see what's going on here, okay? They tell us that they're trying to do this competition for the largest pumpkin. Okay, they say that the average weight of your 2 pumpkins has to be bigger than 875 pounds. Greater. So that's obviously right there. It's telling us it's going to be a greater than when we write this inequality. Because whatever the average is must be greater than 875. So right away, I'm just thinking of the equation. The right side is going to look like that. There's going to be something over here has to be greater than 875. So I already know that's going to be my sign, and that's going to be what's on the other side of it. Okay, now we just have to figure out what goes in the bubble. Okay, so remember, it was the average weight that has to be bigger than 875. So that means in this bubble, we need to write what the average weight of these pumpkins would be.
Is this for A?
Yeah, this is all for A. So, do you guys know how to find the average of something?
No.
Okay, good. Let's start there because that's something that's going to come up on your SAT.
If it's only 2 pumpkins, you add them together and divide by 2.
Yes. Since it's 2 pumpkins, we're going to add the weights together, divide by 2. If there were 3 pumpkins, we'd add all 3 together and divide by 3. If you want to find the average of however many things, you just add up all the things and then divide by how many there were. Yeah.
What do you mean by add them all up?
So like,
Together or like the weight?
yeah, add them up. Put them together.
It's the weight? 8.
The weight.
Oh, 8 digits.
So the problem here, because if we keep reading, they say one of the pumpkins weighs 903. So I know one. I'm going to start with 903 and add the second pumpkin, right? But they're asking us, what does the second pumpkin have to be? What's the least amount it could be in order to win the prize? So we don't know what the second pumpkin is. What do we use when we don't know what something is?
Oh, no.
Question mark?
X?
Or an X? A variable, right? Something to hold a place. So if I'm writing the average, like Bryson said, there's only 2 of them, so we're going to add up the 2 pumpkins. The first one was 903. The second one we don't know, so we'll put 903 plus X. And then we have to divide it by 2 because there's 2 pumpkins. So now, after we read through the whole problem, we've used every single number that the problem gave us. All the information, we used it to make the inequality. Now, we just have to get X by itself, and that'll tell us how much the pumpkin would have to be to make all of this work, to make sure it's bigger than 875. Okay, so we have a problem like this with the fraction. How do we get rid of the bottom?
Multiply.
Multiply by it. So we want to do the left side times 2, and then the right side times 2 also. So on the left, those are going to cancel. And then we'd be left with just 903 plus X is greater than, what's that, 875 times 2, 1750, I think. So this is still technically for part A. Part A wants us to write the inequality, and then it doesn't say solve it, but we're going to solve it. And then we'll talk about B and C. Okay, so there's only one more step now to do. How do we get rid of the 903? Subtract it. Minus 903, minus 903. And remember, since we didn't divide or multiply by a negative, we don't have to switch the sign. The sign just gets copy and pasted. So the answer is going to be X is greater than, what's 1750 minus 903? Yeah. 847. So what that tells us is that the smallest that second pumpkin could be to make sure that the average is over this would have to be bigger than 847.
Then we multiply that by 2. Oh, no.
We're done.
Oh.
Yeah, that's it. Because remember, they asked what the second pumpkin would have to weigh in order to make the average over 875, and X was the second pumpkin. So this tells us that as long as the second pumpkin is bigger than 847 pounds, the entire average is going to be bigger than 875. Because this is a solution to this inequality. So does the solving part seem like okay? Like, do you guys feel okay multiplying by the bottom and then subtracting the 903? Do you guys have any questions on that part? Part A. Okay, part B wants you to describe in words what quantities would actually work. So like if we're talking about the weights of pumpkins, explain it to me in words. Like what would the pumpkin have to weigh? Yeah, more than 847. Just what our answer says. X is bigger than 847, and X was the pumpkin, so the second pumpkin must weigh more than 847. That's all you're going to put for B. The second pumpkin must weigh more than 847 pounds. Okay, so for 12 now, we're talking about an average again. So we're going to add them up and divide by how many there are. But now we're talking about test scores. And there's 3 of them. So to find our average test score, we have to add the 3 test scores up and then divide by 3. And what this tells us is that they want the average, it must be at least 93 to get an A. So if it's going to be at least 93, can it be greater than 93?
Yeah.
Can it be equal to 93? Yes, but it can't be less, right? So for the inequality, the right side of it is going to say greater than or equal to 93.
I don't know about you, but this one.
Because we know the test score has to be greater than or equal to 93. What? A.
Number 8.
Oh yeah, this is for part A. Yeah.
How do you make it big?
Okay, now let's think about the left side. Okay, how would we write the average test score? There was a 93 on one. Oh no, sorry. Got an 89 on the first test and a 94 on the second test. And the third one we don't know, right? So what are we going to use for the third one? X. So to find the average, we'd have to do 89 plus 94 plus X, whatever that is, which is what we're going to find, and then divide it by how many? 3. However many test scores there were total, that's what we divide by. Even though we don't know the third one, we know there was 3 of them, or there's going to be 3 of them. So we would divide it by 3. So it's pretty much the same type of equation. We just have to solve this one now. Multiply. I knew what you meant. So let me... It worked. Okay. So if this is our equation, like you said, we got to multiply by 3 first. Times by 3. Times by 3. Okay, so on the left side, that's going to cancel. So we'd be left with 89 plus 94 plus X greater than or equal to, what's 93 times 3? Thank you. Thanks for following along. 279. So we're going to have to get rid of both of these, correct? So we got to subtract them. So are you guys okay with, would you rather like add them up and then just subtract whatever that is? Okay. So what's 94 plus 89? 183. So I'm going to subtract 183 from both sides. So that's going to cancel all of that. That's going to leave us with just an x greater than or equal to 96. And what did x stand for? The test score. So that means that for that person, that third test score,
You almost got an A+.
well, he would have to almost get an A+ in order to make the average work. So yeah, because to get at least a 96, that's 96 or above, that's pretty much an A+ almost. So if he wants to keep an A average in the class for his tests, the third one would have to be at least a 96. Okay, and that's what part B is asking you. Part B says again, describe in words the quantities that would work. Any test score above 96. Or technically 96 or above.
I think Aaron's got an A+.
Any score 96 or above. So a lot of you guys have asked me before, like, what do I have to get on this test? Like, what do I have to get to keep an A in the class or something? You could actually make an inequality that would tell you that. You would take all your test scores, add them up, and then put a plus x for the last one, divide by how many there are, and then make sure it's greater than or equal to 90, which would be an A. So this is stuff that you could actually use. I mean, but yeah, I don't know.